So welcome back to this session. We are still on factors that affect photoelectric effect, and we are on to our third factor, the energy of the radiation. In the other session, we looked at the intensity of the radiation and also the type of metal. And here is our last factor, the energy of the radiation. We can use this simple setup to see how the energy of a radiation affects photoelectric effect. In this circuit, we have a photocell here with the cathode, and we have a microammeter that is to detect very small currents. On it, we have a potentiometer which we'll use to vary the voltage across this setup. And then we have a source of EMF. Then we are going to have a color filter where we'll shine different radiations onto the metal plate. And for each and every color, therefore, for example, you can have red light, you can have blue filter, it will give us the blue radiation. We can have the yellow filter, it will give us the yellow radiation. I would like you to note that this plate here, onto which will be shining the radiation, the plate is connected to the positive terminal. Please note, initially we were shining this on the plate that is connected to the negative terminal, so that after the photoelectrons are produced, they are attracted to the positive terminal. But here we have now interchanged. This is plate A, and the plate A is connected to the negative terminal. Then the plate onto which we are shining the radiation is connected to the positive terminal. Why this? Notice that this radiation, after the electron is ejected, we notice that the energy of the radiation is divided into two. The first part is used to dislodge the electron. The second part is used to give the electron the kinetic energy. Therefore, we expect that kinetic energy now will be used to cross over this gap to plate A. Now, we connect this plate to the positive terminal so that immediately this electron is ejected, we vary the voltage. Note, after the radiation is shown on this metal plate, we'll have the electrons being ejected. The excess energy will be used to cross over to this, and therefore we shall set up some small currents which will be registered by the microammeter. So what are we looking at here? We are looking at a situation where we shall vary the voltage until we don't register any current at the microammeter. What will that voltage do? This voltage, after this radiation ejects the electrons, at this time the electrons can cross over using that excess energy, which is the kinetic energy. So we'll be now varying the voltage so that this plate has enough potential to absorb back those electrons. And therefore, that voltage will be stopping the electrons from moving to the plate A. And that is why we call it the stopping voltage. So for every frequency of a radiation, we'll be determining what voltage will be used to absorb back all the kinetic energy that has been given to the electrons. And in simple terms, for every frequency, we determine the stopping voltage. Of importance here is to note that this stopping voltage is absorbing the kinetic energy of the electrons. We have a simple table here showing different frequencies. For example, for violet, it is 7.5 times 10 to power 14. You can see the equivalent stopping voltage is 1.2 volts. This is a radiation of 7.5 times 10 to power 14. What about when we use orange light? It is 4.8 times 10 to power 14. You notice that 4.8 is less than 7.5. And you can see again, its stopping voltage is less than the stopping voltage of violet. Why? The energy that was left to give electrons kinetic energy here is greater than the energy that will be left by the orange light after ejecting the electrons. Therefore, the higher the frequency, the higher the kinetic energy. So when we increase the frequency, as long as it is above the threshold frequency, that excess energy is absorbed by the electrons as kinetic energy. We'll go ahead and see what would happen if we plot this data in a graph. And after that, we'll see what analysis can we do to this graph. But of importance here is to note, as long as the frequency of the radiation, remember it's the frequency that gives this radiation the energy. As long as the frequency of the radiation is above the threshold frequency, the excess energy of that radiation will be absorbed by the electrons as kinetic energy. Join me as we look at the analysis of the graph.